Afternoon everyone and welcome to my tutorial. So as for today we are looking at what we call the limiting reagents under the Moore concept. So we must first understand what the limiting reagent is. So the main thing is that whenever you are doing a chemical reaction, there are things that will lead to not the reaction being complete. Now those things are called the limiting reagents, the one that causes the reaction to stop. So therefore the limiting reagent is defined as a substance that is in short supply of the Moore ratio. So when determining the limiting reagent, we consider what we call the Moore ratio and not the mass or any other things. We must look at the Moore ratio because the moles for any substance, they are able to react with another to bring about completion if they are equal. So now what are some of the factors that lead to a substance not being in short supply? So when doing the Moore concept, we consider a balanced chemical equation in which we are able to predict the amount of substance that can be produced. Now sometimes those substances, maybe you say a gas of 60 cubic decimeter will be produced. Sometimes it might be as low as 40. Now what are those factors? The first thing is that gases are able to escape to the atmosphere. So one of the factors is that gases are able to escape to the atmosphere. The second factor is that some substances are impure, therefore not all of it are able to react in accordance with the Moore ratio. So these are some of the factors that lead to the reaction not being complete. So now, under that, we are now looking at an example. So the example says 19.5 grams of zinc and 9.4 grams of sulfur were heated together. So this is the reaction. So zinc reacts with sulfur to produce zinc sulfide. Now we are asked the question to say, the question says, which of the two is the limiting reagent? So how do we find the limiting reagent? So this is the procedure. So the first thing that we need to do is find the number of moles that are there in each of the following. So looking at this is a balanced chemical equation, therefore we are going to consider the masses that we are given. So the first one, we are asked, so we need to find the number of moles. So we know to say the number of moles we need to find for zinc. The number of moles of zinc should be equal to the mass over the molar mass. So we know to say the number of moles of zinc, the mass that we have been given is 19.5. So we are going to say 19.5 over the molecular mass of zinc, which is 65 grams per mole. So when we do our calculations, we are finding that our number of moles that are present in zinc is equal to 19.5 divided by 65, we are getting 0.3 moles. So in this mass of 19.5, there are exactly 0.3 moles of zinc. Now we need to find the other reactant. So when finding the limiting reagent, we consider the reactants. So when finding the other reactants, we are going to say the number of moles of sulfur should be equal to the same our mass. Our mass for sulfur, we are given it's 9.4. So when we divide the mass number for sulfur, which is 32 grams per mole, then we have grams. So we have the number of moles of sulfur. When we do our calculations, it's giving us 0.29 moles. So of the two, you also ask yourself to say, which of the two is smaller? So this is a 2, this is a 3. Automatically, this is bigger. So it means to say the limiting reagent is the one with less number of moles. Therefore, we can assume to say sulfur is the limiting reagent. our B. Our B, we are asked to say how many moles of zinc remained unreacted. So the number of moles of zinc that remains to unreacted, we are just going to subtract this. So when we subtract, we are going to say the number of moles of zinc which remains unreacted should be equal to 0.3, which is the number of moles of the whole zinc minus 0.29. So from that, we are able to establish that our answer is equal to 0.01 moles. So out of this 0.3, only 0.1 moles of zinc remained unreacted. Now, having considered that, we now look at our C. So we are asked how many grams of zinc element remained unreacted. Now this time they want the grams of zinc which remained unreacted. So it means to say the mass that remained unreacted came from the remaining number of moles. So we are going to say our mass, if we make the subject of the formula, or we can just go mass, number of moles should be equal to mass over the molar mass. So the number of moles, we are going to use this. So we have 0.01 moles should be equal to the mass which we don't know. But the molar mass will remain the same. So we have 65 grams per mole. So we are going to cross multiply. So when we cross multiply, we have our mass being equal to 0. So we are getting a 0.65. So this is the mass of zinc that remained unreacted. Last but not the least, we are asked to say calculate the mass of zinc sulfide formed. So this is very crucial when finding the mass that would be produced for the product. We must use the limiting reagent because it was the one that was in short supply of the mole ratio. So if we are asked the mass, we can use the balanced chemical equation to find the remaining mass. It always has to be balanced. So we are going to say, we can say this. We can use the mass to mass ratio, whereby we can say this for mass, the molecular mass of sulfur is 32 grams, should be able to produce, if the equation is balanced, it should be able to produce the amount of zinc sulfide, of which when we do this, we are getting a 32, a 65. When we add them, we are getting a 97 grams. So we have zinc sulfide. If 32 grams in a balanced chemical equation reacts with zinc, we are able to produce 97 grams of zinc sulfide. So if that's the case, then we get the actual mass that was used. How about 9.40 grams? How much mass will be produced? We do that, then we cross multiply. So when we cross multiply, we are getting a 97 by 9.4. So we are getting a 911.8 should be equal to 32x. We divide by 32 on both sides. We are getting x to be equal to 'So this is the mass that could be produced using the balanced chemical equation as well as using the limiting reagent, because it was the one that led to the calculations or the experiments to stop. So under this one, you can never use the one that was in excess. Why can we use that? Because that substance could in experiments it could produce more than 28.5 because there are some remaining mass as well as moles. So thank you very much for watching the video. Hope you subscribe and follow for more.